Hi again. We're going to do a couple more problems. I'm going to start from the bottom and then go up and write some notes down here. Just remember that our simple derivative rule looks like this. I have two versions. I have a version with a K. Okay, so I have that. And then I also have a version without a K. So the K is the constant. Okay, the K is the constant. So remember that we should always have 1 over x plus 1 or K over x plus 1 or n plus 1, excuse me, sorry. N plus 1 times x to the n plus 1 power. And then we always have to have the plus c on there. Just a reminder, the plus c is a constant. We know that the derivative of a constant is 0, so we have to account for the fact that we might have a constant at the end of this function. We don't know yet, okay? So let's jump down here. So I have a dy. Wow. Okay, so I have a dy. That just means that I have to differentiate with respect to y. So y is going to be in my final answer. So instead of x's, I'm just going to have y. So same idea. So this has a constant, so I'm going to follow this rule. I'm going to copy the constant over, so I'm going to have 4. And then I'm going to have n plus 1. So negative 2 plus 1 is negative 1. Okay, so I'm going to have negative 1. And then I'm going to have y, because it's my variable, y to the negative 2 plus 1 plus c. Okay, and then I'm going to simplify that out. So I'll have negative 4 y to the negative 1. Okay, negative 4 y to the negative 1 plus c. Now, I'm just going to check our work really quickly. I have, if I bring this down, if I take this derivative, if I differentiate on this right side, I should get this integral, or this integrand in the middle. So this is integrand. Okay, so this is negative 4 times negative 1 is positive 4. That's what I have here. And then negative 1 minus 1 is negative 2. So that works. So this is the correct answer. Okay, it's the correct answer. Now, on my second one here, I can think about this as 3 separate derivatives. So I can think about these as 3 separate derivatives, or not derivatives, integrals, sorry, if I wanted to. So that way I could deal with these all separate. So if I deal with them one at a time, I have 9x squared. I'm going to bring the 9 out in front. I'm going to divide it by n plus 1. So it's going to be 3. So 2 plus 1 is 3. I have x to the third, and that's going to be plus c. Okay. Now in the second part, I'm going to bring the 4 out in front. And this is a 1. This is a invisible 1. So this is going to be over 2. And then I have x squared plus c. Okay. And then these are getting added. Okay. The reason why it's getting added is because I have a plus sign here. Okay. That one I'll be adding again because I have another plus sign here. I have the integral of a constant, so that's going to be ax, because the integral of a constant is the constant times the variable it's in respect to, and that's always going to be plus c. Now I'm just combining like terms if there are any. I have 3 c's, but 3 times c is still a c, it's still a constant, so we don't have to write 3c, we just keep it as c. C plus c plus c is still c. Okay, and then we just rewrite this. So I have a 9 over 3, which is 3x cubed, plus 2x squared, plus 8x, plus c. Now just check to take the derivative. I get 9x squared, 4x, plus 8, and then that absolutely works out for us. Okay. Now I have a derivative of just a derivative. Okay, we have to think back when we were doing implicit differentiation. What is the original function of dt? The original function of dt is just t. The derivative of t is dt. The derivative of x is dx. Now, we don't know what anything else about it, so we just have to call this t plus c. Okay, and I want you to think about that. If I had something like x plus 4, okay, the derivative of this is just dx. Okay, the derivative of that is just dx. We could also call that 1. But now since we don't have a variable here, we have to think about this dt in terms of the variable itself. Okay, so that gives us t. And then last but not least, this was a homework problem yesterday. So I have 6 dx. This is a integral of a constant. So I'm just going to get 6x plus c. And you check your work. The derivative of 6x is just 6 with respect to x, which is what this dx here means. And we have plus c. Okay. Please reach out to me with any questions, comments, concerns, issues. Really appreciate you guys doing so much hard work and communicating with me and talking to me. Have a great day.